Hi, Planet Wayne here with the fourth in a series of videos on how to build a working shooting range. Purpose of today's video is how to code up the controller, the Programmable Rednet Controller that's needed to glue all of the functionality together with all the lanes and to bring online the control board here that we've got, or control panel that we've got. Video 3, if you caught that one, was all the modifications that we needed to the build with regarding the extra Rednet cable that goes across the lanes, also the sort of block placements and so on for the lamps, and a few minor adjustments that are needed underneath, again with extra Rednet cable that ties all these things together into this last controller module. Before we jump into the main programming logic here on this end controller, there's a bit of a correction I need to make to some of the information that I was giving out in video 3 here. If you remember, we were actually recoding a spare slot, slot 8, that redirected the reset line from the new controller that we're about to go over, and I'd mistakenly got the input for that slot on the B channel, or the B face of the controller. Now that typically B is for back face, not down face, and we actually need to change that to D for down face. So down on black goes through to upper on purple that we've got on here. Again, sorry for that one if it's caused any confusion. Typically it wouldn't have broken any lane designs as such, like operating in individual mode, because we've not tied it back to this main controller yet, but just needed to throw that out there just to make sure that, as I say, that needs to be the bottom, did it again, the down face of the controller that passes it through to the upper face for the reset button. Okay, we're at the end controller here, and I'd just like to show you the expansion slots in the front of this. Now, the whole thing takes up 25 coding slots, or 25 function slots within the controller. Now, to get there, what I've used on this one is a combination of the LX500s, 300s and 100s. So there's 3 of the 500s, 1 of the 300s and 1 of the LX100s, and that gives a complete total of 25 programming slots. We're not big use on the actual variable usage as such on this. We do use a few in there, but not that many. But again, mainly it's to do with the programming slots that we need the expansion cards on there. Now, the other way of doing this one, typically we could use just LX500s in there, and that only needs 4 of those. We end up with 26 slots available on that one, so there's 1 not used at the end of that. But again, from a point of view of future expansion, it gives us the ability to drop in some more cards if we need to. This one's obviously got 2 slots available to it, and that one's only got the 1 extra slot. So just needed to mention that just before you start crafting all of this, that we will need some expansion slots to go through that. Okay, we're in slot 1 of the controller. As you can see, there's 25 slots there available to us on this one, and again, that's due to the expansion cards that we've got sat in the front of it there. And the first couple of slots that we're using are to detect or set variable 0 based on the fact that we have a wind detection. Now, I'll stick the table up, if you remember from last time, that had all of our different colours and different functions and such like on there. So each of the lanes, if you remember, has got a column for the gate being set, for a wind detection going on, and also for the reset. So I'll stick that up at the bottom again so we can see what's going on with each of these colours. But this one is basically an input that's coming from the down face of the controller, so that's coming from each of the lanes, and we've got lane 1 on orange, lane 2 is on yellow, and lane 3 is on pink. And we're using an OR comparator in this, or a 4 input OR gate, to basically keep the content of variable 0 set high if it's already set, and detect anything that's coming in on these 3 and push the result back out into variable 0. So this is working as a kind of latch function at the moment to keep variable 0 set to high if it detects something coming in on each of these 3 on that one, and the remaining 2 for lanes 4 on purple and 5 on dark green. Again, just keeps variable 0 high if it's already been set, or actually makes it high if we've got an indicator or wind indicator coming in on these 2 variables. Slot 3, we're using an AND gate, and basically that is taking the content of variable 0 and ANDing it with the upperface on the black channel. Now if you remember from the controller, the black channel is actually the game selector line, so if that's high, then all of this gets activated by the fact that we're using variable 0 throughout the rest of this to do various functions and that sort of thing. So if we've got a win coming in from the win detection on the first 2 slots, and we're in the multi-mode or lane versus lane mode that we've got selected with the selector, then we keep that value back out on variable 0. Right, slots 4 through 8, and this is where we start getting into groups of slots here, based on the number of lanes that we've got. So the 5 slots that we've got on 4 through 8 are to set the winning lamps above each of the lanes. And again, we're doing this using an SR gated latch. Again, reset is coming from upperface on white. The set is coming from the fact that we've got a pulse coming in on the orange channel for lane 1, and we're also enabling this with the fact that we've got variable 0 been set as well. So a combination of all of those 3 there. The output for this is coming out on the upper face, and if you remember before I was saying keep the colours the same for input and outputs and such like for the lanes that you've got, just to make it easier to decode or debug later. And this is a classic example here. So wind detection is coming in for lane 1 on orange, and we're sending out the lamps on the upper face again on orange. So that gets repeated another 4 times for each of the remaining 4 lanes. The only difference being is the colours that we're using on here. So the next one is yellow. So again, yellow lane 2, pink on lane 3, purple on lane 4, and dark green on lane 5. So as I said before, we're resetting on upper face on white, we're setting on the lane colour from the down face, we're enabling this from the fact that variable 0 has been set, and we're setting the output for it on the upper face, again on each of the colours that correspond to the lanes there. So that's that's slots 4 through 8. Okay, slots 9 through 13, again this is another group of 5, and this is to set a variable based on the losing lanes. And the way that we're doing that is by using an XOR gate, or a 3-input XOR gate. Now the way that it works is an XOR gate basically sets, it's the same as an OR gate, but it's exclusively one input or another and not both. So if we've got more than one of these inputs that are set to being high or on, then the variable actually gets set to a 0. So in this instance here, we're actually looking at the one for lane 1 here. So if we've got a win, we're always going to be detecting a win, so that's going to be coming in on variable 0 here. But if the win is coming in from lane 1, then this input is also going to be high, which means that this output is going to be low because it's an exclusive OR gate. So based on that, then the only way that this the output for here is going to be set to a high is if there is a win and it's not on this lane. And that gets used a little bit later on, or variable 1 gets used a little bit later on to actually then close this lane down. Now the reason that it's a 3-input OR gate is or 3-input XOR gate, sorry, is we've also got another input that's coming from the upper face on this dark blue channel. Now again, remembering that control panel that we'd got set up, the dark blue channel is the one that we use to shut the lanes down. So these variables actually get used to activate the drawbridge controllers or the drawbridge blocks underneath the lanes to shut them down in the event of losing, or in the fact that somebody's pressed that button. So that's how this is working on here. Slot 9 is for lane 1, and again, input on orange, output on variable 1. Slot 2 is slot 10 is for lane 2, input on upper face on yellow and output to variable 2 this time. Lane 3 is input for upper face pink, output to variable 3. Lane 4 is upper face upper face purple and output on variable 4. and lane 5 is upperface dark green and output to variable 5. So again, exclusive OR or XOR gates with the 3-input version of this is allowing us to shut down our losing lanes, or if somebody presses the button, to shut down the lanes at the end of the day. And again, that works on the basis that only one of these can be available or high at any one point in time, and that's the thing that sets that variable. So that's slots 9 through 13 is for the losing control, or the shutdown of the lanes, to put the drawbridge blocks up in front of the losing lanes there. Okay, 14 through to 18 again is another group of 5, and this is using something called a Schmidt trigger to tidy up the transitional period between the variable getting set between its low state and its high state. And again, I don't know if anybody's actually used electronics in the real world, but Schmidt triggers are used to smooth out that transitional period between somebody pressing a button and then the actual output to be registered as high. Now, although you might think in the real world that, okay, I'm pressing that button, it's a fairly quick thing, from an electronics point of view, there is an element of noise that gets introduced into a circuit. And what a Schmidt trigger does is actually tidies that out and just clears that out of the way. And again, in this instance, that's exactly what we're using it for on here. So 14 through to 18, each of the variables are going up. So in this one, we've got variable 1 as an input and variable 1 as the output. We're using this PD value, which is the time it waits to sort of tidy the signal up effectively. And that's set to a constant 2 for each of them. I did try slightly less, and I wasn't getting consistent results with that. Slightly longer, and you do notice as well that there's a little bit of an extra delay that gets introduced between the gates actually closing. So certainly in my example that I've got here, 2 seem to work out the best. Certainly try it out and change it if you're getting any problems with the variables being set on that one. So slot 14 is variable 1, slot 15 is variable 2 on input and output, 16 is variable 3, 17 is variable 4, and 18 is variable 5. And as I said before, this is basically using a Schmidt trigger to tidy up the fact that this variable is being set. Slots 19 through to 23 is our last block of 5, and these are using SR latches to control the gates that come up in front of the lane. So we're always taking a reset from our upper face on white, which again, if you remember, is our reset button back on the control panel. The set for each of these are coming from the last set of 5 variables that we've got set each for the different lanes, so that'll increase through variables 1 through 5. And our outputs that are coming out are always going to be going on the down face, and that'll be the colour there will be associated with the table that we've got going on at the bottom. So for lane 1, obviously our input variable is variable 1, and our output is on the downward face again on the white channel. Next one for variable 2 is output on the down face for light blue. Then we've got variable 3, which goes out to dark grey. Variable 4 goes out on cyan, and the last lane for lane 5, variable 5, outputs on the down face, and that's on the brown channel. Slot 24 is a D latch, and we're using that to reset the content of variable 0. So the input from it is coming from the upper face on white, which, as you remember, is our control panel, and that's the reset button. It only gets enabled when variable 0 is in a high state anyway, so it doesn't matter if you keep spamming the reset button, it doesn't change anything on here. And the output is, instead of being the normal Q output, which would be high to say that this gate or this latch has been set, it's actually the inverse of it. So the inverse of a high in this instance is obviously low, and we're sticking that back into variable 0. So that's how we're resetting our wind detection line with this function on slot 24 here. We've finally made it to slot 25, and this is the reset line to send reset signals to each of the lanes. And the way that we're doing that one is quite simply from the upper face on the white channel, which again on our control panel is the reset button, and we're using the fan out feature on here to send that signal to the down face and each of the color codes for the lane resets. So lane 1 was on magenta, lane 2's on green, lane 3 was on this light grey, lane 4 is on blue, and lane 5 is on red. So again, looking at the table below, that just sends a reset signal which is coming from this reset button through fan out and sends it to each of the reset lines on the bottom face, or the down face of the controller there. Well, that's it from me, Planet Wayne. Thanks a lot for watching. Hopefully this was informative and gives you some ideas on how to create a working shooting range. There's a few more bits and pieces, hopefully you'll take inspiration from this, that could be done in so much of giving each of the lanes different colour codes and so on. Obviously, design ideas are completely open to interpretation. It's really the programming logic that sets all these things, or makes all these things work here. Again, expansion, there's certainly room in the controller there for a few more programming slots and so on, so we could quite easily add probably a good few more lanes onto this if you wanted to make a bigger version. Obviously the control panel as well will allow us to take more inputs and such like, and more displays on there, so that really isn't a problem. But as I say, that's it from me for now. Hopefully some likes and comments below, and I shall catch you in the next video. And thanks a lot, and bye for now.